Hi guys, now we're on lesson 2-4, solving equations with variables on both sides. It's kind of tough, but I think you're actually going to kind of like this lesson. I don't know, the tougher they are, the more interesting they seem to be, at least to me. So our objectives would be to solve equations with variables on both sides, and that's just the same as the title. But we're also going to introduce something new here. We're going to have equations that are going to be called identities. So that just means that they're always going to have a solution, and then equations that have no solutions. But that comes towards the end. Okay, so look at the getting ready box on page 102. It says the diagram gives information about populations of two towns. After how many years will the populations be equal? So most of the word problems in this chapter are going to be about, well, you have this and you have this, and they're supposed to be set equal. So after how many years? So let's let our variable y equal years. Will the two towns be equal? So if we put an equal sign, and let's say we have town A on the left and town B on the right. After how many years are they going to be equal? Well, town A has a population of 3,225 right now, and its yearly growth is 100 people each year. So that's going to grow at a rate of 100 people every year. So 100y. Now, town B has a population of 3,300 people, and it's growing at a rate of 75 people per year. So if we solve this equation for y, you'll figure out in how many years they're going to be equal. But that's how we're going to have to set up these equations, and you'll get much better at these as we go through. Okay, so problem 1, let's actually solve one with variables on both sides. So we have 5x plus 2 equals 2x plus 14. Now, if you're gonna solve this for the solution is going to be x equals. Well, I have x's over here and I have x's over here. So when you have variables on both sides, you just have to decide which side you want the variables to be on. And it really doesn't matter, but usually one way is easier than the other way. So let me just walk you through the two cases. Now, I'm going to write one way, and then I'm going to erase it. So don't write this first one down, because this is going to be the harder of the two. Okay, let's say I want my variables to be on this side. Okay, well, if I have 5x over here, in order to get rid of the 5x over here, I have to subtract 5x from both sides. So I have to subtract 5x from this side. Now, combining like terms, you can only subtract 5x from 5x. So on the left side, 5x minus 5x would cancel out, and I would be left with 2. I still have this 2 right here. And on this side, 2x minus 5x would be minus 3x, and I still have the 14. Okay, that's one way. Now, oops, sorry. Okay, here's your other option. If I have 5x plus 2 equals 2x plus 14. I would say it's easier if you move the 2x, because then you don't have to work with negatives. So you kind of want to look for the variable that's smaller. 2x is smaller, so if I subtract 2x from this side, and I hate when I underline them because then people think that I'm using division. I'm just underlining them to point them out. But subtract 2x from both sides. So over here, 2x minus 2x, that's 0x. So that completely cancels out, and all I'm left with is 14. And then on the left side, 5x minus 2x is 3x, and then just drop down the plus 2. You're going to get the same answer either way, but I always like to avoid negatives if possible. So now we have a two-step equation. Just solve it from there. Subtract 2 from both sides, so we have 3x equals 12. Divide both sides by 3, and you have x equals 4. Okay, so it's definitely important to remember all those steps from lessons 2.1, 2.2, and 2.3, and now we just have to worry about if we have variables on both sides. Okay, so the answer would be x equals 4. Alright, got it, number 1. what is the solution of 7k plus 2 equals 4k minus 10? Now it's up to you which side you put the variables on. I think it would be easier to move the 4k over to this side, because 7 minus 4 would give me a positive number. So in order to eliminate the 4k from the right side, I have to subtract 4k, because 4k minus 4k would be 0. I also have to subtract 4k from this side. Okay, 7k minus 4k is 3k, and I just dropped down the plus 2. Now, one thing that a lot of people do is they'll just write 10. But make sure you keep the sign that goes in front of the number. So since that was a subtract 10, now you want to write down minus 10. It's still a negative 10. You want to make sure you don't lose track of the negatives. Okay, and then solve the two-step equation. Subtract 2 from both sides. So I have 3k equals negative 12. And at this point, you could probably solve these in your head. You don't have to keep writing divide by 3, but you divide both sides by 3, and you get k equals negative 4. Okay, and that's it. Pretty simple. Okay, now let's actually go from a word problem and make an equation. So use an equation with variables on both sides. Alright, it takes a graphic designer 1.5 hours, so 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours. So do you see how with the new software he can do it a little faster? But it takes him 8 hours to learn the software. So how many web pages would the designer have to make in order to save time using the new software? Okay, how many web pages? So let's do W stands for web pages. So it takes a graphic designer 1.5 hours to make one page. Okay, so that was the old way. It takes him 1.5 hours. Oops, sorry. So 1.5 hours per web page, right? So we don't really want to put 1.5h. It's 1.5 hours per web page. So if you're making 1, it's going to be 1.5 times 1. If you're making 2, it's going to be 1.5 times 2. Okay, using the new software, he can complete each web page in 1.25 hours. So every web page is going to take 1.25 hours per web page. But it takes you an extra 8 hours just to learn the software. So you have to add on 8. Okay, so I don't know. I think a lot of people might have got confused and tried to use the variable h in there somewhere. But that's just per hour. What you're actually making every hour is web pages. If you look at the book, they use the variable p, but it's okay. We use w for web pages. It's all the same thing. Okay, now solve this for w, which would be how many web pages the designer has to make in order to save time using the software. Alright, I'm going to subtract 1.25 w from each side. So I'm going to put a 0 on here so I can go through and I can borrow. Make that a 10. Make that a 4. So 5.25, right? $1.50 minus $1.25 would be 0.25. Web pages equals 8. Now, I don't know how much you know about converting fractions to decimals, but 0.25 is just 1/4. So this equation is really 1/4 w equals 8. Now, I mean, you could use your calculator, but the more of this you can just do in your head, the better. If I have 1/4w, I'm just going to multiply both sides by 4, and I get w equals 32. Alright, now, that's not exactly the question. What the question says, well, how many web pages would the designer have to make in order to save time using the new software? Well, at 32 web pages, it's equal. So 32 web pages isn't your answer. That's where the two different ideas are equal. You would have to actually make 33 web pages in order for them to save money, because 32, they're equal. That's what we did. We set the two equal to each other. So if you're going to actually save money, anything over 32, so now 33, 34, 35, would actually be saving you time. Okay? Okay, got it, number 2. So let's try another one of these word problems. An office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill for the office from $112 to $88. And how many months will the copier pay for itself? Okay, how many months? So let's make our variable. M stands for months. Hopefully you're getting good at that, at deciding what the variable is. Alright, so you have two different situations. You have the before. Well, instead of saying before, let's say old and new. Okay? The old situation was it cost you $112 a month. Right? It will reduce the monthly electric bill for the office from $112. So that was the old electric bill. The new electric bill is going to be $88 per month. But you had to spend $650 for that new machine. So on the new machine side, we have to add on $650. Okay? Because right now, if you're just paying $112 a month, that would be $112, and then another $112, and then another $112, and then another $112. Do you see how it's going to take you a while to make up for that $650? Even though now the cost is a little less, the cost each month is a little less, it's going to take you a couple months to make up for that $650. So figure out how many months. So variables on both sides. Let's subtract 88M from both sides. Okay, so let's see. Make this a 12. Make this a 10. I'm going to have to borrow again. And I'm not using a calculator on these. You can use a calculator. For 24 months is going to equal 650. Right? Yeah. Okay, and then when we divide both sides by 24, and I grabbed my calculator for this one, 650 divided by 24 is actually 27.083333. Okay, so the question is, in how many months will the copier pay for itself? So in 27 months, about 27 months, the copier will pay for itself. So it took you 27 months just to make up the difference. So some companies would say, well, 27 months, that's 2 years. Did I really need to spend that extra $650? It all depends on how long you're going to keep the copier for. If you're only going to keep the copier for 2 years, and it's going to, maybe 3 years, and it's going to take you almost that much time to make up the difference, then you probably don't want to spend the extra $650. But if you're going to be using this copier for the next 10 years, well, after 27 months, you're going to be saving a lot of money. From 88, you're going to be saving $24 every month, and that's going to add up pretty fast. So people do this as their job. They kind of like analyze which, what they should do. So if I ask you this one is one of the got it questions, I never really decide until the end of the video. Just put in as your answer. I know it's about 27, but just put in 27 months. Okay, that's what I'll put in. So if I put got it number 2 as one of your questions, just put in 27 months. Okay, now we have one where you have to do the distributive property, and you still have variables on both sides. So let's see, we have 2, and then parentheses 5x minus 1 equals 3, parentheses, x plus 11. What a lot of people try to do is they try and start subtracting the 5x or the x before they have variables, before they do the distributive property. Like, they try and subtract x here and they try and subtract x here. But you have to go through and distribute first before you can start moving variables. Okay, because it's really not going to be x, it's really going to be 3x, right? Okay, so the distributive property, we get 10x minus 2, and then 3x plus 33. Now think about which variable you want to move so that you don't have to move negatives. I would say subtract 3x from both sides so that 3x minus 3x cancels out. So we get 7x minus 2 equals 33. And then finish the two-step equation. Add 2 to both sides. 7x equals 35. Divide both sides by 7, and you get x equals 5. Okay, so make sure you do the distributive property before. Like, I'll show you certain cases where you don't have to, but in this case you have to do the distributive property before. Okay, got it, number 3. Now, here's a situation, part A, where you don't necessarily have to do the distributive property, but we'll do it just so we know we have the right answer. So, let's see, we have 8y plus 4 equals 2y minus 26. I would subtract 2y from both sides. So I have 6y plus 4 equals negative 26, because that's a negative 26. I'm going to subtract 4 from both sides. So I need to put that over here. I have 6y equals negative 26 minus 4 more would be negative 30. Divide both sides by 6, and you get negative 5. Okay, one way we could have done this differently, let me just add some, well, here, I'll leave this so we can see both of them. If we would have done 4 times 2y plus 1 equals 2y minus 13. Now, I'm not really suggesting this because I think the distributive property is easier, but do you see how the two numbers that you're going to distribute share a common factor? When that happens, you can divide this whole thing by whatever the common factor is. So if I divide this whole piece by 2 and this whole piece by 2, see how this 2 and this 2 will cancel out? And then 4 divided by 2 is just going to be 2. So the problem becomes 2 times 2y plus 1 equals, and then on this side we just have y minus 13. So then you still have to go through and distribute over here, but you don't have to distribute twice, so it's really just a matter of opinion. You're still going to get the same thing either way. I'm going to get 4y plus 2 equals y minus 13. I'm going to subtract y from both sides, so I'm going to have 3y equals, and then I'm also going to subtract 2 from both sides. 3y equals negative 15, and divide both sides by 3, and I get y equals negative 5. So if you can do that when the two numbers that you're multiplying share a common factor, but I don't know. To me, it seems like the same amount of work, and I would rather just not worry about having to, can I do that, can I not do it? So I usually just always do the distributive property. Okay, like right here, 3 and 7, they don't share a common factor, so you have to do the distributive property. So we have, when we distribute, we're going to get 28 minus 7a equals 3a minus 12. Now, this is the first one we've come to when we have variables on both sides and one's actually a negative. This one right here is a negative. Because the 3a is definitely smaller, but if you subtract 3a, you're going to have negative 7 minus 3, you're going to have negative 10. What I would do is I would add 7a to both sides. And then you just have to worry about positives again. So negative 7a plus 7a cancels out. So you have 28 equals 3 plus 7 is 10a minus 12. Add 12 to both sides. You get 40 equals 10a. Divide both sides by 10, and you get a equals 4. Okay, so I would just go through and distribute. I think it's easier to do it that way. Let me scrunch this back down in case you want to pause this and look at the whole thing one more time. Okay, there's really only one piece of vocabulary here. An equation that is true for every variable is called an identity. If I gave you this equation, x plus 5 equals x plus 5. No matter what number you plug in for x, if you add 5 to it, it's going to be the exact same on the other side. Something like this, so it's usually not that simple, but sometimes if you have like 2x plus 6 equals 2 parentheses x plus 3. Well, if I distribute this second half, I get 2x plus 6. So this would be called an identity because the two sides are exactly the same. And I'll show you what happens when you solve that. But some equations have no solution. So if I end up getting this, x plus 5 equals x plus 9, well, whatever number I put in for x, if I add 5 to it, I'm always going to get a different answer than if I add 9 to it. Okay, so that's just like two different cases. You either get a number, like exactly one number, or it's called an identity, or it has no solutions. Okay, so what's the solution of each equation? So for part A, this half is already done, so we have 10x plus 12. Then let's do the distributive property over here, 10x plus 12. And just pretend you know nothing about this. So to give variables on the same side, I would subtract, now it really doesn't matter here, right, because they're both 10. So I would subtract 10x from both sides. And 10x minus 10x is 0. So I have 12 equals, well, 10x minus 10x on this side is 0. And so I have 12. So when you get a situation like that, 12 equals 12, this is called an identity because it's true for any value that you plug in for x, you're going to get the same equation. Now, if you want to, you could have stopped right here. 10x plus 12 equals 10x plus 12 is the exact same equation. But if you want to go through and solve it and get a true statement, 12 equals 12 with no more variables, you could do that as well. Okay, number 9, they actually threw something extra in here. So we have 9m minus 4, and then on this side we have 3m plus 5 plus 12. So these two m's on this side you have to combine first. So we actually have 9m minus 4. Now negative 3 plus 12 is going to be 9m. So we're going to have 9m, and then we still have the plus 5. So keep solving it. Okay, get variables on the same side. I'm going to subtract 9m from both sides. Well, those cancel out, and I'm left with negative 4. Those cancel out, and I'm left with 5. So negative 4 is not equal to 5, so this is an example of no solution. And again, you might have been able to tell from right here. Well, if I take a number and I multiply it by 9 and subtract 4, I'm never going to get the same answer as if I take that same number, multiply it by 9, and add 5. So if you get something where it's a true statement, like 12 equals 12, that's an identity. If you get a false statement, negative 4 equals 5, that's a no solution. Okay, let's do got it number 4. So what's the solution of each equation? It's going to either be no solution or identity. So let's see. We got to distribute here on part A. So 3 times 4b would be 12b, and 3 times negative 2 would be minus 6, equals negative 6 plus 12b. Hopefully you realize that those two sides are the same. 12b minus 6 and negative 6 plus 12b is the same. So you could stop there and say identity, but let's say we keep going and we subtract 12b from both sides. 12b minus 12b cancels out. We have negative 6. Over here we have negative 6, and 12b minus 12b cancels out. So what is the solution of each equation? You just say that this is called an identity. That's your answer. I mean, your answer isn't -6. Your answer isn't -6 equals -6. Your answer is that this is an identity equation. So every number that you plug in for B would be a solution. Okay, and part B. Let's see. We have 2x plus 7 over here. On the right side, we have to distribute. So -1 times 3 is going to be -3. And -1 times -2x is going to be positive 2x. Again, hopefully you can see 2x plus 7 and 2x minus 3 is not going to be a solution, but if you want to, subtract 2x from both sides, just as if you were getting the variables on the same side. Those cancel out, and we have 7 equals -3, and those cancel out. Because that's not a true statement, what's the solution of each equation? Well, there is no solution. There is no number that you can put in that would make both of these sides true. Okay, then this is just a key concept summary here. We've gone through, they don't get any more complicated than this. So this is kind of your order, like almost like a checklist. Step 1, if you need to use the distributive property, do that first. So anytime you see parentheses, you should do the distributive property. Okay, then if you need to combine any like terms on the same side, like if you need to combine like terms on the left side, combine those. If you need to combine like terms on the right side, combine them. And then step 3 is what we did today. Use the properties of equalities to get the variable terms on one side. And then from there, you're going to have a two-step equation. So use the properties of equality to solve for a variable. Either it's going to be a two-step equation or a one-step equation. And then check your solution. You can do that if you want, if you have time. But if you're very careful in solving it, then you should know if you got it right or wrong. Okay? And that's it.